Welcome. Today we are going to discuss on chapters of IR spectroscopy. Today we will discuss in exam point of view. So detail we will discuss in later classes. So today the basically our topic will be that basic persons or that the persons which will be very important for exam point of view. This IR spectroscopy here, what the radiations is radiations used is infrared, and this IR spectroscopy it is used to identify the functional group. And in IR spectroscopy, what you see is that the basic for this IR spectroscopy is the basic concept, the chemistry concept is used, that is dipole moment. Dipole moment where you use the polar difference. Polar difference, let's say if you have that carbon and hydrogens. So here the polar difference is, let's say this carbon, that electronegativity is 2.5, then it is 2.2. So there is a polar difference, that is 2.5 minus 2.2, that is equal to 0.3. It has a polar difference. Wherever if you say C upon C and CC bond, then what you see that here also 2.5, here also 2.5 electronegativity. So here that polar difference is 0. 2.5 minus 2.5, that is a 0. So these are the polar compounds, these are the non-polar compounds. So here the dipole moments means the polar difference we will discuss. So in the whole chapters of IR spectroscopy, we will talk about this polar difference. Okay, and here that range of data will be, that is 2.5 micrometer to 25 micrometer. But this range is very small, you see. So that this range, so if this range is there, then that data will come, that is very complicated. So that data, that spectra will complicated, and because the space is very less, so we will change into a wave number, that is 4000 to 400 centimeter inverse. Okay, and in this another one, the formula of this is this is the stretching frequency, or we know that the energy values that we change into centimeter, so that we will divide it, that we have clearly discussed on physical spectra. This formula, wave number formula is 1 upon 2 pi c under root of a upon this reduced mass. Okay, this formula we have to remember here, that this is the where this is this new bar is dependent on the stretching frequency, and this k represent that force constant, or also we say that this is bond strength, and this mu represent that reduced mass. Let's say if you have C and H bonds, then let's say it has the mass m1, let's say it has the mass m2, then this reduced mass will be m1 into m2 upon m1 plus m2. Okay, so from this formula what you understand is that this stretching frequency is directly proportional to this force constant or bond strength, and also this stretching frequency is indirectly proportional to this reduced mass. It means from here what we understand that if that bond strength, let's say this is equation 1, let's say this is equation 2. So from equation 1 what we understand, if this K, or that is bond strength, increases, then that stretching frequency will be increases, because that is the directly proportional. And from equation 2 what you understand, that if reduced mass increases, then stretching frequency will be decreases. So how you explain that? Let's say if you take out examples, and if we say that CC bond and C double bond C, let's say C triple bond C. So here that bond strength is increases. Let's say this is A, let's say this is B, C. So here C bond strength is 3 bonds are there, so its strength will be high. So if that bond strength is high, then stretching frequency is also high. So that bond strength is that is C greater than B greater than A, then this stretching frequency also greater than B, A. Similarly, if you talk about another example, let's say if we have that CCl bond, CCBr bond, and C I bond is there. So here what we say that here that reduced mass, let's say this is A, let's say this is B, let's say this is C. So you see that reduced mass of C is greater than B greater than A, then this stretching frequency will be inversely proportional to the reduced mass. So this will be going to become. So these things we have to remember that from this formula. Another thing is that if the resonance is there, let's say group like if you have CO and H2, let's say JCS3 is there, another is let's say CH3 CO H is there. So for this case we see that here that conjugations or resonance is there. Okay, so this is going to here and this is going to here, or it may be this is going to here, or I can say the examples. This is also fine, or you can take the same example, H3CO and H2. So here that this is happen here and H2 plus. So due to this resonance here, this double bond is going to change the single bonds, but here this is same. So here that due to this bond from double bond it could come into single bond, but here the double bond remain as it is. So if the double bond means double bond is stronger than single bond, so bond strength will be here. Okay, so these things we have to remember. Okay, and one more thing that, so before we doing that IR data, we have to remember one more thing, that is if any functional group, if any functional group 2 or more than 2 identical atoms are presents, then the one functional group we get two peaks. Okay, so it means that what it says that what I actually are doing the IR data. So first I have to give some notes. I forgot to give. So before coming to this point, let me keep one note so that our IR data is 4000 to 400 centimeter inverse. Okay, so this data has that two groups. One is fingerprint region and one is functional group region. Okay, and this fingerprint regions, it that range is from 400 to 1500 centimeter, and for this functional region, this range is 1500 to that is 4000 centimeter inverse. Okay, and in these fingerprint regions, mainly there's bending modes are there, bending modes of vibrations, and here that stitching bonds, stitching modes of vibrations are there. So whenever you talk about of this fingerprint regions, then we will talk about of this bending modes, and whenever you are talking about functional group regions, then we are talking about of stitching modes of vibrations. And in this fingerprint regions, the range is 400 to 1500 centimeter inverse, and whenever you are talking about a functional group regions, then the range is 1500 to 400 centimeter inverse. Okay, so this fingerprint regions we will not discuss more, because that these fingerprint regions, like we have our fingerprint is different for different persons, like every person's the fingerprint is different. So if the fingerprint is different, then how will identify that a group? Because every group they will give the different this value, IR value. So it is not useful to identify the functional groups. So you will use this functional group, because if any groups have the same functional group, then that this IR data will give the same value. So you will use this functional group data to identify the what the functional groups are present. So we will talk about of these functional group regions, and we will not talk about of fingerprint regions, because these fingerprint regions not give the informations about any functional group. Okay, so if any functional group, if it has two or more identical atoms, on that case that functional groups will give the two peaks, not one peak. Okay, let's say we have that groups like CH3 COH. So it will give that only this aldehyde, this carbonyl functional group is there, so one peak it will give. Let's say 725. Its range is 700 to 725 centimeter inverse. We will discuss it. But if here that one atom is there, but if the case is, let's say CH3 CO O COCH, like anhydride case. Here what we see that in the same functional group, two atoms are there. Let's say this is that one atom range, and this is the one different. Means same atoms are there, CO and CO. So you say that if two or more identical atoms are present, then the one functional group we will get two peaks. So here that any one peak will get in this range. Let's say 750 centimeter inverse, but here that peak we will get, that is two peak we will get. Let's say 750, another let's say 810. So this type of peaks you will get if the group has more than two identical atoms. Okay, so these things we will use in the whole of our IR data. So now we will discuss about this IR data. This is very important for exam point of view. So we'll discuss IR data and that is only which data, that is functional group region. We will not discuss on fingerprint regions. Okay, this functional group regions, that range is, what the range, that is 1500 to 4000 centimeter inverse. And here what type of vibrational modes are there? Stretching modes of vibrations. Okay, so here we will discuss only these functional group regions, and the range is 1500 to 4000 centimeters, and here only stretching modes of vibrations we will discuss. Okay, so this IR data I will divide into 6 types. Okay, so one types we say that this that we know that this IR spectroscopy is full. This is detail about this is we are talking about of dipole moments. Dipole moment means that it's polar difference. Okay, so that we know that polar difference is there, then that uh, its IR data will give different. If different polar groups, then they will give different IR data. So let's say first if I say that CH. Okay, so here that polar difference, we know this is 2.5, this is 2.2. So here that polar difference is there, so it will give some IR data, some functional group regions. And let's say we have that CC. So here that polar difference is 0. Okay, so for that we will get some data. And if here that, let's say CO, 2, 3, and let's say another, if you say OH, and let's say this is 4, let's say yes, CCCOH, let's say NH5, and that says NO. Okay, so this 4 we will discuss, or I will. Let's say first type we will discuss about of CH, and secondly we will discuss about of let's say CC, and let's say you discuss about of C double bond O, discuss about of OH, you discuss about of NH, discuss about of NO. Okay, this is 1, 2. So these all the cases, what are the IR data will be there. So from here we see that if there is a polar difference, if polar difference is high, not that these points, if high polar difference, then this IR data will be high value. High IR data, high IR value, or high this stitching frequency. Okay, so here we see that what is the polar difference here. Let's say with the CH, so we know these groups, that is you can say that here higher the polar difference, higher will be stitching frequency. Okay, so this is very important points. This will helps to identify that what is the polar, what is the IR data. Approximately we can identify that by understanding these points. Okay, higher the polar difference, higher will be the stretching frequency. So here we see that what is the polar difference between this. So this is 2.5, this is 2.2. Okay, so let's say we know that this hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So whenever you moving from left to right, this left to right, electronegativity increases. It means that from here to here, that polar difference will be increases. So here that you see that CH. So if I talk about of this CH, then let's say this carbon is 2.5 and this is 2.2. The polar difference is nearly 0.3. The polar difference is 0.3. And let's say this, the polar difference is 0, and here the polar difference is a carbon and oxygen. So carbon, that electronegativity is 2.5 and it is some value nearly about of 3, something like that. Okay. I not remember the exact point. The polar difference is, let's say, 0.5, and here that oxygen, this hydrogen is 2.2 and oxygen is, let's say, 3, then polar difference is nearly 0.8. And here nitrogens, let's say hydrogen is 2.2 and nitrogen is, let's say, 2.8. Then this polar difference I'm taking about of approx, and this polar difference will be let's say it H 2.9. Then this polar difference is, let's say, 0.6. And this nitrogen oxygen, nitrogen, let's say 2.9, and let's say this is 3. Then I'm taking about of approx, then its polar difference is 0.1. So here we see that these are the polar difference. Polar difference here 0.3, here 0, here 0.5, here 0.8, here 0.6, here 0.1. So here we see that where the polar difference is high, and that stretching frequency will be high. Okay, so we can get the some idea about of what should be the IR value. Okay, so for this we see that here that polar difference is very low. So here that IR data value will get nearly about of 1100 centimeter inverse. Okay, and here also the very less value. So here that IR data value will get IR data value is here 1100 centimeter inverse, and here also very less value. So here also the IR data value will be 1350 centimeter inverse. Okay, that range means we understand that what is the, from this polar difference is very less. So from that we understand that here we see that very high polar difference. So here we will get that IR data value will be 3600 centimeter inverse. Okay. And here we see that this is about of 0.6. So here you get something 3 centimeter inverse. Okay, and from here that polar difference is 0.5. We said this carbon and oxygen. Okay, so this carbon is let's say this carbon is 2.5 and oxygen is how much you're taking, that 3. Oxygen is we are talking about a 3, then its polar difference is 0.5. See here, C double bond O is there, so its polar difference is, you will get nearly, that is 700 centimeter inverse. Okay, and for here this is polar difference 0.3. For this some other region is there, so here that IR data is nearly this value, and for this value 0.3. Okay, so this is going to give something about a 3000 centimeter inverse. Okay, so from this polar difference we get the idea about what should be this IR value. Okay, now we will discuss detail about of this CH, CC and CO and OH and NH and NO, the stretching frequency. Okay, so this point you have to remember, higher the polar difference, higher will be the stretching frequency. Okay, so now we will discuss one by one. First we will discuss CH, then we will go for CC, then we will go for this. Okay. First topic will be IR data stretching frequency of CH bond. So this value is nearly, we say that 3000 centimeter inverse, 3000 centimeter inverse to some values. Okay, this will come. Okay, so now we will first discuss that CH bonds where it is available. Okay, so CH bonds we can get, either we say that CH, and this CH maybe, let's say that this C is from sp3 hybridizations. Let's say this, or I can let some value of R dash, sorry, R dash double dash. So this CH, I'm talking about of this CH. So the stretching frequency of this CH bond. Okay, so this IR data value, this stretching frequency values will be the stretching frequency value will be 3000 centimeter inverse. Okay, and now if the CH, and if now this is sp3, now if it has sp2 type double bonds. Okay, now let's say this R1 and this C, and it has some like this, sorry, like type of groups, then this value will be this range, that is this C8 sp2 hybridized, here C8 sp3 hybridized. Okay, so for this case, so here the double bond has come, so whenever this double bond has come, then this electronegativity means S character is high, so electronegativity increases, so its IR value will be increases, its value will be 3100 centimeter inverse. Okay, and similarly if I talk about of CH, and that is, this is at sp3, let's say like type bonds, then this CH will be, the stretching frequency of these bonds will be, this is something about a 3300 centimeter inverse. Okay, and if let's say if it is aldehyde groups also CH is present. So let's say CH3 COH. I'm talking about of this CH. The stretching frequency value will be two values you will get, that is due to that Fermi resonance we will discuss later. So this value we will get two values. One is 2700 centimeter inverse to 28,000 centimeter inverse. Another we will get 28,000 centimeter inverse to 29,000 centimeter inverse. Okay, so we see that as that electronegativity from this here, the electronegativity of this is less, because while moving from single bond to double bonds, sp3 to sp2 sp here, that s character is increases. S character means increases, means electronegativity is increases. So if electronegativity is increases, then this stretching frequency will be increases. Okay, so from CH it is 3000, then from sp2 is 3100, then at sp3 that is 33,000. And whenever you come to the aldehyde groups, here also CH group is present. So here that due to this electronegativity, uh, electron withdrawing groups, so its value will be decreases. Okay, here all are electronegativity is increases. Okay, but here you can get the electron withdrawing groups, so its value will be decreases from that CH normal sp3 CH. From 3000 to it decreases to 2700 to 2800. This value will get one data, means in this range. Okay, one value we will get, and anywhere and other than this we will not get any CH bonds. So in ketone CH bond is not there. Let's say CH3 CO CH3. So here we say that if I talk about of C, here H, here H. Here also that CH bond is there, but this CH bond is similar to this sp3 bonds. Okay, similar to this sp3 bonds. So we will not talk about of aldehyde ketones. So in this four cases we have the CH bonds, and this IR stretching frequency data is this data. Okay, so you have to remember this data. Now we will move to next groups, that is CC bonds. That is stretching frequency of CC bond. So what we say that the CC bonds, the range will be very less, that is 1100 centimeter inverse, because the polar difference is 0. Okay, so past here also we will discuss about that is, let's say any CC bonds. CC bond means let's say any groups like here any group is present. So this type of stretching CC bonds means a single bond is there. Okay, so here that stretching frequency will be, this value will be 1100 centimeter inverse. And if double bond is there, CC double bonds, then we know that as that I'll discuss that as we say that stretching frequency is equal to 1 upon 2 pi c k upon reduced mass. So if this force constant, this is bond strength increases, then reduced mass will increases. So from single bond to double bond, okay, here single bond, so this value, so double bond it is high bond strength, so its value will be increases. So its value will be increases to 1650 centimeter inverse. Okay, and for C triple bond C, again that now the two double bonds were there, Previously now 3 double bonds are there, so its value will be again increases. That increases to 200, 100, 2150 centimeter inverse. Okay. Now with this another bonds I will discuss here, that is similar to that, but this is not CC but the same, that is C double bond L here. Okay, so here that polar difference is 0, but here that N and C polar difference is there. Also 3 bonds are there, so this uh, stretching frequency will be increases to 200, 2250 centimeter inverse. Here the two factors is working. One factor is polar difference, another factor is more number of bonds. 3 double bonds are there. Okay, so that's value will be going to get 2250 centimeter inverse. Okay, so this is the stretching frequency of CC bonds. Now we will discuss to third type, that is CO bonds. Now we will discuss third is stretching frequency of C double bond O bond. Okay, so here we will say that bond here stretching frequency. So wherever the stretching frequency will be there, the CO bonds. So first CO bond is like we say that aldehyde ketones and acyl groups. This is CH3 COH aldehyde, CH3 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 COOH. Here that this CO double bonds and this CO double bonds, everywhere the stretching frequency will be it's found that they have the nearly same stretching frequency, and its range is that is 700 to 725 centimeter inverse, 735 centimeter or 700, that is 725 centimeter inverse. Okay. And whenever we discuss about of this next will be let's say CH3 COLH2. So we have discussed that if that any aromatic conjugations is there, then that stretching frequency will be decreases. What you see that here, if you do that, then what it can be happen, thus this can move here. So CH3 CO and H2 plus, this is also possible. It means that due to this resonance, what you see here, from this CO was double bonds, that's decreased into CO bonds. So you know that when CO bonds, here double bond here, there here single bond is there. So if the bond strength is decreases, then stretching frequency will be decreases, because bond strength is directly proportional to stretching frequency. So its range will be decreases from this value. So this is going to give nearly about of 1650 to 1680 centimeter inverse. Okay. And now if I discuss about of this where also we will find that CO bonds, that is if I say about of ester CH3 CO CH3. So here also resonance is possible. I can do the resonance. Let's say this will comes here, then what we will get here, that CH3, this will become single bond, this will become double bond, this again CH3. But what we found here is that previously we have this as the double bonds. Now again this CO is double bonds. Means both the cases CO is there. Means that here first case this the CO double bond, here CO is single bond. Now we are talking about of CO only. We are not talking about of Cl. So CO, that stretching frequency will be decreases. But here you see that here also CO is there. After doing resonance also CO is coming. It means that here due to resonance, as the CO bond is remain as the CO bonds, so its stretching frequency will be increases. Okay, because both the cases CO bond is there, so its value is stretching frequency will comes more than this, that is 750 to something like that is 1810 centimeter inverse. Sorry, that is 700. This value will be 735 to 750 centimeter inverse. Okay, so this value will be 735 to 750 centimeter inverse, not 750 to 780. Okay, this is the correct data. Okay, so this value will be increases from this value because both the case after resonance also CO voltage remain intact. Okay, now third case, third structure, let's say where the CO is available, that is let's say CS3, CO and O, CO anhydride group. So here we see that here also CO bond is there, here also CO bond is there. So if in a functional group, if two or more than two atoms are identical, then they will give the two peaks. And here we see that this CO here, that resonance is there. So this value will be increases, and since that same groups two are there, so it will give the two peaks. Okay, so its peaks will be something like 750 to 810 centimeter inverse. Okay, because here the two atoms are there, so we discussed that if a functional groups have the two identical atoms, two or more than two identical atoms are there, then as one functional group will give two uh, stretching frequency value. So it's two stretching frequencies, one is 750, another is 1810. Okay, here that one IR data is there, that is in between this one value will come, but here the two IR data will come, one is 750, another 1810. And we know that for symmetric stretching that the IR data will be always less, so this is for symmetric stretching, this is for asymmetric stretching. Okay, so you know that symmetric stretching is, let's say any groups, let's say this, uh, let's say this type of groups. So this is also here, this is also here, this is called same way, this is the symmetry. And let's say one is here, another is here, this is called asymmetric stretching. Okay, so symmetric is always less value, that is 750, and asymmetric is always high value, that is 1810. Okay, and other groups where that CO is available, that is CS3, CO, Cl. Okay, so whenever you talk about of halogens, then what we say that here minus I effect is dominate, effect dominate, that plus M effect. So here we see that although here lone pair is there, but plus M is not dominate, minus I is dominate, so it is taking the electrons from here. So if it is taking electron, then it will get positive charge, so it will obstruct electrons from oxygen. So it means that overall what we see that this CO bond strength is increasing, so it's that stretching frequency value will be increased. If CO stretching, if CO bond is increases, then we know that bond strength is directly proportional to stretching frequency, so its value will be increases. That's value which find nearly about of 1800 centimeter inverse. Okay, now if you have similar loop like CS3 CO F is there, then on that case again this is minus effect is less for that, but here that minus effect is very high fluorine group. It will be more abstract, means more electron to abstract, means that your strength is more high, so its value will come 1870 centimeter inverse. Okay, so these are the about of that CO stretching frequency. Now I will discuss fourth type, that is OH stretching frequency. So its value is nearly about 3600 centimeters. So this is just for that how you approximate the what the value should be. Okay, from this polar difference. Next is, that is for stretching frequency due to OH bonds. So you have discussed that its polar difference is, let here we say that free OH, where no hydrogen bonding is there, free OH. So here polar difference is very high, that's why you see that here the stretching frequency, that is we get nearly about of 3600 centimeter inverse. Okay, now if hydrogen is here without hydrogen bonding, now if hydrogen bonding is present, then there is two cases we get. One is intra and one is another is inter. So for intra case we will get less value compared to that, that is we will say that the value is something 3300 to, or it is 3200 to 3300 centimeter inverse, and for inter it will get high value, that is 3300 to 3400 centimeter inverse. Okay, this is about of this OH stretching, and that peak will be here, that peak will be, we will get that broad peak. Okay, so now next types we will discuss, that is NH stretching frequency, and its value is also nearly equal to this OH stretching frequency. So now we will discuss about a fifth type, that is stretching frequency due to NH bond. Okay, so here that I will discuss about a bond, here the stretching frequency. So here we will discuss first case is 1 degree Min, their NH groups. So this value we will get, so here we will get the two peaks for symmetric and asymmetric. So this we say that, so here that we know that same atoms are there for this NH, so you will get that two different peaks. So we have discussed that if atoms have two identical atoms, then we will get for one functional group two peaks we will get. So one peak is here, that is 3300 centimeter inverse, another is I think 3500 centimeter inverse. 3400 centimeter inverse. This is for symmetric and this is for asymmetric. Okay, and for 2-degree amines we will get only one peak because here no identity atoms are there. So 2-degree amines we will get that is 3100 centimeter inverse to 3500 centimeter inverse. So we see that OH and NH, the stretching frequency value is nearly same. So how we will identify which is NH and which is OH stretching frequency? So for an OH stretching frequency, the peak is generally the broad. Okay. So from here we identify if the broad peak is there, then we understand that that is the OH, the stretching frequency due to OH bonds. Okay. And last types we will discuss, that is 6, that is stretching frequency due to NO bond. Okay. So here the bond, here I will say the stretching frequency. So here also we see that this NO, the two atoms are similar. So here also you get the uh, two peaks, and we know that this values. So this the polar difference is very less. So it's get the very less value 1350. Okay, and for we see that here that same. So polar difference is very less. So 1100. Okay. So this polar difference is very less, so we will get the peaks. Each one is 1350 and another is 1550 centimeter inverse. This is for less is for symmetry and high is for asymmetry. Okay. So these are the all about of this IR data. So we must have to remember this data, and because in the exams we that NMR data will given, with that IR data will given. So with that we have to identify the structure. So from here we identified that what the structure should be. Okay, what the structure should be nearly large. Okay, so here we see that CC, the stretching frequency is, the polar difference is very low, so that is 11, that is 0, so that is 11 centimeter, the lowest. Okay, after that we will discuss about of that we'll discuss about of the factors, like if CC the single bond is this and CC double bond will comes, then due to that uh, bond strength is increasing because single bonds to double bonds, so bond strength increases, that's why that stretching frequency also increases. So past one will be the 1100 lowest. Okay, after that we will see the factors, whether this bond strength increases or not, whether reduced mass is increased or not, like that we will discuss. But the past factor we will discuss by looking about of this polar difference, and we will idea about of what should be the range it lies. Okay, and for this CO bonds it is other factors will be there that we will discuss. So that range is 700 centimeter inverse. Okay. So today up to this, thank you.